So welcome everybody to this amazing webinar, seminar, or however you want to term it, an online show where we're looking at improving the sustainability of livestock production. I'd like to maybe just set the scene a little bit in the kind of global context of what we're actually doing on this show, because we know that the world is facing many multiple existential challenges, from climate change to the loss of species to high levels of pollution. And we're also facing increasing resource constraints, what people call pinch points. Indeed, according to some experts, we're even running out of sand to actually make glass. Meanwhile, we've had the COVID pandemic, and it has shown to us how vulnerable our global supply chains of materials and products can be. And climate change, of course, is only going to aggravate these challenges with supply chains as we go forward. Geopolitical relationships are changing very fast, with important implications for our societies and our economies. The circular economy is one highly promising way of addressing some of these multiple challenges. And the concept in respect to the more efficient use of natural resources is at the heart of the European Union's Circular Economy Action Plan. Today, we're going to look at animal feed and feed additives, and more specifically, phosphorus. We know that humans need phosphorus, it's essential for life, and it is an additive for animal feed, but it's also important for fertilizers and in other industries like electronics and fire safety products. Traditionally, it has been supplied from phosphate mines from countries like China, the United States, Russia, Morocco, and its Western Sahara. This has implications for climate change because of the emissions associated with this mining and the transportation, plus impacts on natural landscapes. Importantly, for this program, the European Union is 90% or over 90% dependent on imports. Because of this limited availability of this scarce resource, the European Union includes phosphate rock and phosphorus on its list of critical raw materials. So today we're going to look at the extraordinary potential for actually looping back this material, this phosphorus, into the European economy from the recycling of what are often thought of as waste materials. We're also going to focus on whether policy legislation and policy at the EU has actually truly evolved to support these kinds of breakthroughs. My name is Nick Nuttall. I'm the Strategic Communications Director of We Don't Have Time TV and We Don't Have Time, which is the world's largest review platform for climate and environmental action, headquartered in Stockholm, Sweden. I'm your co-host. The webinar is going to come in two halves. We're going to look at the potential to recycle phosphorus from sewage sludge, for example, using a new process. We're going to look at scientific studies and findings on its use in animal feed. And we're also going to look at the political challenges on recovering nutrients and getting them back into the economy and out into the market. In the second half, we will have a discussion with policymakers and also with one of Scandinavia, if not the world's, leading experts on resources and circularity. We're going to hear a little bit from what they think about what they've heard and what they think about in terms of moving forward for a more resilient and sustainable EU. Let me here also introduce my co-host, which is Per Larssons, who is the Director of Sustainability at the environmental company Ragn-Sells, and I know a passionate advocate of circularity. Per, over to you.
Thank you, Nick. Nick mentioned about the first half, there will be a lot of presentations. We will more than welcome any questions that you might have to the speakers. And in the end of the first session, we will address them, your questions. And if there is a lot of questions, we make sure that we answer each of them. So please use the chat function to make sure that you interact with us and ask relevant questions for the topic. Secondly, I would like to also address and say that the whole project is funded by the Lantmännen Research Foundation together with Ragn-Sells. I think I now switch over to you again, Nick.
Super, Per. Great to have you here. Okay, just before we get the things rolling, I'd also like to thank Sarah Stjernstrom, who's the project manager or product manager of EasyMining, who has in many ways organized today's seminar. And EasyMining is an innovation company which is part of the Ragn-Sells group. Okay, so let's get moving. We've got our first guest lined up. It's Ludwig Herrmann of Proben Consulting in Austria, and he's also chairman of the European Sustainable Phosphorus Platform. Ludwig has some 35 years experience across 3 continents in the area of technology and business development, and among his many achievements is co-inventor of the ash decontamination and phosphorus recovery process. Your title is The Potential of Recycled Resources from the Wastewater Sector. Ludwig, you have the floor.
Thank you very much, Nick. And you took already some of the aspects that I will bring up during my presentation to the introductory phase of the webinar. So I will talk about the potential of recycled resources from the wastewater sector. And first address the main challenges that we have. We don't have a good water quality status in Europe. We are transgressing the planetary boundaries for P, phosphorus, and nitrogen. We continue increasing CO2 emissions, and we have, on the other hand, ambitious sustainable development goals. And first and foremost, we have an increasing population to feed, and we need fertilizers and feed additives to feed our population. So, making a long story short, what we need is decoupling. We need to decouple materials use from growth, economic growth. And the best tool to get to this is a transition from a material-based to a service-based circular economy. You mentioned it. We need to produce more value with less impact, with less materials. In response to that, the European Commission has developed the Green Deal, and there's a central part of it, the farm-to-fork strategy. And the core objective of the farm-to-fork strategy is to reduce nutrient losses. And the goal is very ambitious. We talk about 50% loss reduction before the end of 2030. And we also talk about converting more farmland into organically managed farmland. So the overall goal is 25%, almost achieved by countries like Sweden and a few other EU countries. But the average of the whole EU is just by 8% of land under organic farming. And what we want is to achieve a food system that is compliant with our climate goals, and which is good and fair for producers, consumers, and the environment. And in support of these goals, we have now a new common agricultural policy that assigns 25% of support payments to farmers to eco schemes, meaning sustainable management practices. And we have a new circular economy action plan. And this circular economy action plan includes several areas with a high potential for circularity, among them food, water, and nutrients, specifically mentioned. Let's say, core legislation coming out from these strategies and action plans is the fertilizing product regulation that has a strong focus on circularity and on including recycled materials, including bio-based fertilizers. What we don't yet have is a similar regulatory framework for feed additives and feed phosphates. So currently it is prohibited to use phosphate resources, wastewater-derived phosphate resources. Nick talked about the European resources that we have, and indeed we have one mine in Europe that is operating currently in Finland. It is Siilinjärvi, producing roughly 160,000 tons of P per year. And if we look at our system flows, we have a total input of about 2.4 million tons P into the system, and we have an output of about 1.5 million tons. So roughly 1 million tons is stored in soil. But if we look a second time at these output flows, we have about 1.2 million tons in terms of waste, of which roughly 650,000 tons consumption waste, essentially sewage sludge, because our excreted P is in sewage sludge. And if we look at the market for feed phosphates, we are using in Europe roughly 350,000 tons per year, and the ratio of feed targeted phosphate is much higher in Europe than in the global average. The ratio in Europe is about 23 to 25%, and the global average is 5 to 7%. And we have now also two pathways forward. One of these pathways is that since October last year, we have a scientific opinion from the European Food Safety Agency confirming that ash is almost 100% safe. The estimation is 99 to 100% in terms of pathogens, in terms of organic pollutants that may present an hazard to human health. And we have an initiative that was undertaken by the European Sustainable Phosphorus Platform together with 110 federations, companies, EU projects, and scientific partners to define more areas where we could have an end of waste status. And our initiative was referring to wastewater treatment. So this is my short framework presentation, and I don't want to forget to invite you to Vienna in June to come to the fourth European Sustainable Phosphorus Conference. I thank you very much, and I give the floor back to Nick. Thank you.
Thanks, Ludwig. And the idea of coming to Vienna in that time of year sounds absolutely wonderful. Okay, so now we're going to go to Martin Braunersreuter. He's head of sales, industry services at Gelsenwasser in Germany. Martin will be the CEO of a newly created joint venture between EasyMining, Germany, and Gelsenwasser, with the goal to build the first ash-to-phos plant in Europe. And it'll be located in Schkopau in Sachsen-Anhalt. That's what it said on the map to me anyway. Your theme, Martin, is making process recovery happen in Germany. Martin, great to see you. You have the floor.
Yeah, thank you, Nick. And yeah, thank you, Sarah, for the invitation and the opportunity to share our view and our opportunity for phosphorus recovery in Germany. You can hear me very well because I have some troubles with the connection. However, yeah, first of all, I would like to share some slides about Gelsenwasser. Gelsenwasser is a pretty old company which was founded in 1887, and the main goal was to supply the growing industry in the rural area with water, and also the population, of course. We are mainly driven by municipal shareholders, which is about 50% of the municipality of the city of Bochum and the city of Dortmund. And our activities are, we are a multi-utility company. We supply water, we do wastewater treatment, we have some natural gas activities, we supply electricity and also some district heating. And our activities are, of course, mainly focused on the rural area. However, we have some activities also in the north, in the city of Bremen, for example, also in Sachsen-Anhalt. And in Sachsen-Anhalt, we intend to have a phosphorus recycling plant in the future. So, but what background? Mainly we are driven by our government and by political parties. And already in 2013, political parties have agreed, the governmental part has agreed on a strategy for a recycling of phosphorus. And main drivers is we want to safeguard raw material stocks, but also to reduce Germany's dependency on imports of phosphorus. The second main driver is that we don't want to have more pollutants in the soil, so we want to restrict pollutants which comes with raw phosphates from, for example, North Africa to Germany or to other countries. We don't want them to have in the soil. So the requirements for the process were set by the government or by politicians already. So, and we want to have a high recovery rate for phosphate in the process. We want relevant quantities, so which really can substitute imports of phosphate, stable and good quality, of course. So the huge sludge regulation have been amended in 2017, which means from 2029 on, there's no sewage sludge as fertilizer allowed anymore. In the beginning for big plants, and then from 2032 also for smaller plants, wastewater treatment plants. Actually, what we see is that the way forward is and will be a sludge incineration. So a lot of sludge incineration plants only for sewage sludge will be built or are under development actually. And we see a market potential for at least 700,000 tons of ash a year. And therefore, actually in our own project, we assume having 60,000 tons of ash per year from our own incineration. So these are the locations of two of our incineration plants. One is in Bremen, the other one in Bitterfeld-Wolfen in Sachsen-Anhalt. And there we have already started up the test period for the incineration. So we already have the ash. So what we did is we cooperated with EasyMining. This is a longer story. I will cut it short. We had some trials with other technologies and other companies, but in the end, for us, it was really important to have a company which we can rely on and which has the same view on how to handle the recovery recycling. So we founded in October the new company Phosphorgewinnung Schkopau GmbH, sorry for the name, which is a 50-50 joint venture between EasyMining and Governmental. And it is our goal to have the first full-scale ash-to-phos plant running, let's say by beginning mid-2024. With a first plant, we aim to recycle phosphorus from ashes from other suppliers in Germany as well, not only from our own plant, because we want to have we have the ambition to optimize the processes and the costs. Therefore, we need a greater variety of different ashes from sludge incineration in Germany. Why did we choose for the EasyMining process? First of more reliable process, and this is very important for us, reliable partnership. The second thing, and this is, I think, the key, I think also for the discussions today, is we want to have a detoxification of the sludge. We are sure that the ash-to-phos process will help us to detoxify the ashes and will separate all the valuable raw materials, which is phosphorus, but also aluminium, ferric, and the sand in the end. We'll separate these raw materials to market-ready products. We chose for a concept in which a chemical park plays a valuable role. For us in Germany, it's very common to concentrate these industries in these park shared infrastructure. And then we chose for the park in Schkopau, in which we already only operate the wastewater treatment plant. You see the red market area in which we will build the phosphorus recycling plant. And yeah, of course, it's easy to understand that we can make use of all the logistics, all wastewater treatment facilities, but also of the utilities provided by the park operator. We're in process. In 2021, we decided on the location because there were other options as well. And we founded the phosphorus recycling company. And we finished the basic engineering, and we already had in some applications for public funding to build the plant. We prepare the permits for the building process, and there we are more or less 90% ready. The final investment decision, when we get the funding for the project, will be done somehow in the Q2 of 2022. What is our vision or our rollout for the future? So first, we will start with the plant in Schkopau, in which we, in the beginning, will treat approximately 30,000 tons of ash a year, which then will lead to a capacity of 15,000 tons of calcium phosphate, which is a product from this process. I think Jerry will give us some more insight on that later on. The second step will be then to increase the capacity at the location in Schkopau by doubling or maybe 3 times the starting capacity. But in the end, we have to go to have more plants running in Germany with a total capacity of approximately 300,000 tons of ash, which can then produce approximately 150,000 tons of calcium phosphate a year. So yeah, as I thank you for your attention, but also thank you for the invitation, and thank you that we were able to share our views on phosphorus recycling in Germany.
Thank you, Martin. Thank you. Yes, thank you very much indeed. And that sounds very exciting, going from concept to a real plant doing this. That's really good news. Our next speaker is Dr. Yariv Cohen, who is head of research at EasyMining. Yariv is focused on the recovery of resources from waste using chemical processes, and he has had a key role in the development of 7 patents, including the ash-to-phos technology. And he's also part of a collaborative project under the EU LIFE program on the recycling of other key substances from for example, wastewater and nitrogen. So your theme, Yariv, is from sewage sludge ash. It's quite hard to say sewage sludge ash very quickly, to recovered feed phosphate. Thank you.
Thank you, Nick, for the introduction. I will jump into the presentation directly. First, I would like to say some word about EasyMining. EasyMining is a daughter company in the Ragn-Sells group. Ragn-Sells is a large Swedish recycling company. You can see the figures here down to the right. In the whole group, we treat about 6 million tons of waste per year. The group is active in 4 countries, number of employees above 2,000, and we're active in four different countries. EasyMining is a daughter company in the group, and our main mission is to work with the more advanced technologies to produce commercial and to recover commercial products out of wastes. We focus very much on the nutrient recovery from waste. Currently, we are commercializing 4 technologies that you can see here on the screen. We have ash to phos, which I will talk in this presentation. It's about phosphorus recovery from sludge ash. But we have also a technology to recover salts from fly ash from waste incinerators, in which we can recover potassium. And we are in the stage of constructing the first full-scale plant for this technology north of Stockholm with a capacity of 150,000 tons of ash per year. And then we have also technologies that are directed towards nitrogen recovery. We have a technology to produce ammonium phosphate in an energy efficient way and to recover nitrogen from liquid waste streams. If we talk a little bit more about ash to phos, it is a technology that enables to recover clean phosphorus product from sludge ash. In this picture here, you see the linear flow of phosphorus today in society. It starts with the mine, this red puzzle brick here. We mine the phosphate, it goes into the industry, to the fertilizer industry or the feed industry to produce a product for agriculture. We use it in agriculture, transport the food into society, and then the phosphorus ends up in wastewater treatment plant, in sewage sludge. And when the sludge is incinerated, it ends up in the ash, and ash today is disposed as a roll. And there are some problems associated with that. The lifetime of the phosphorus reserve is limited. It's a fossil reserve. It will end in future. Another problem, as we heard, Europe is heavily dependent on import of phosphorus to 90%. There are also some political problems because the world reserves are in the hands of a few countries. And another big problem is that there is a large content of heavy metals such as cadmium in rock phosphate, which contributes to health problems in society. So our mission with phosphorus recycling and the ash to phos technology is to put this puzzle piece and to enable to create a loop to recycle phosphorus from the ash, from the incinerators of sewage sludge back to the agriculture through feed products or fertilizer product. And in that way, we can close the loop for phosphorus. Then, if we look at sewage sludge ash, it contains not only phosphorus, and when we develop a process, we need to consider all other components of the ash. And we have actually managed to recycle almost all components of the ash. We have the phosphorus product, as Martin said, in form of calcium phosphate. We have a silicate sand that we look for application in cement and concrete industry. And we have iron and aluminium that are added in wastewater treatment to catch the phosphorus from the wastewater, and they end up in the ash, and we enable to recycle them, to separate them, to be reused in the wastewater treatment plant. And of course, we have the heavy metals that we separate for disposal today, but in future, it can be a source of copper, zinc, nickel for other applications. The ash to phos process is a wet process. It's based on wet chemistry. We dissolve the ash in acid. It's the same way like the phosphate or feed industry dissolve the rock phosphate with acid. We use the acid and lime in the process. And as you can see here in the illustration, we separate the heavy metal. It's a small fraction. It's about a few percentage of the weight of the ash for disposal and for future recycling in the future. We recycle the iron and aluminium as coagulants that can be reused in wastewater treatment. We get the silicate sand that can find application in cement and concrete, and the phosphorus that can be recycled to agriculture. Regarding the recovery rates, in this figure here, you see the how sludge ash looks like. It's like cacao, I would say. The red color is due to the iron content that is added in the wastewater treatment plant. If we focus on phosphorus, then the recovery rate is like in these figures here. It's above 90% for phosphorus, 60 to 80% for aluminium, iron 10 to 20%, and calcium 80 to 90%. But we have another process mode that if we want to recycle more of the iron and aluminium, we can increase the recovery rate to above 95% for all these four elements here. So it depends on the economy and the target and the aim. But there is a possibility to get a really high recovery rate for all components. And this slide is very important because in the ash to phos process, we have a decontamination step. Sludge ash come from sewage sludge, and to the wastewater treatment plant, you can add very different waste streams that can contain heavy metals. And we have a very efficient detoxification method that ensures that the recovered phosphorus is clean, independent on the initial composition of the ash. And here you can see an example of recovered P, content of heavy metals in milligram per kilogram, and the original content of heavy metals in the ash, and you can see the reduction in percentage. So we are close to 100% for many of the heavy metals and above 96% for the one that is in the lowest percentage. So the product is very clean. And here you can see a comparison of PCP. It stands for precipitated calcium phosphate, and compared to rock phosphate, typical value. And I don't know if you see my arrow. If we look at the fluorine, we can see that there is a very big difference. And fluorine is actually toxic for animals, and this is the reason why rock phosphate cannot be used as an animal feed. You need to defluorinate to remove the fluorine in order to enable it to be used as a feed material. And the precipitated calcium phosphate is extremely low in fluorine and also in all other heavy metals. So it's a very good source of, I would say, the cleanest raw material on the market that is also recycled. Another example, we could look at the cadmium content, which is extremely low in the precipitated calcium phosphate compared to rock phosphate. And we know that there are many diseases in society that are caused by cadmium that accumulates in the human body. I think this is my last slide, and I hope you get some insight about the ash to phos process and what the capabilities of this process. Thank you.
Thank you very much indeed, Yariv, and that was quite a fascinating insight in comparison between the rock phosphate and the phosphate you're getting out of the sewage sludge. That was really quite fascinating. Okay, so let's go to our next speaker, a leading scientist at the Swedish University of Animal Sciences in the Department of Animal Nutrition and Management. This is Professor Magdalena Ragn-Sells, and she's had a glittering career in this field, focusing especially on nutrition in pigs and also in poultry. I can't mention all her credits, but she has previously worked from the university's EPOC entity, which is the Center for Organic Food and Farming, and she's also the focal point in Sweden for the European Federation for Animal Science. Magdalena, you have been, I understand, doing trials on pigs and poultry with recovered phosphorus, and your theme for this talk is digestibility results from tests with a recovered feed phosphates. So you have the floor, Magdalena.
Thank you very much. Yes, I will focus my presentation now on the part of the project that has been run with some studies to determine the digestibility of phosphorus with this recovered feed phosphate that we have been heard about. So first of all, we have mentioned it previously, so I will just slightly go through why phosphate feed additives are needed. Well, as we know, phosphorus is a vital ingredient for life, and if we don't feed our animals with it, they probably would get restricted growth. It could end up in deteriorated appetite, disrupted bone and mineralization processes, and decreased productivity, especially regarding the digestion of feed and digestive disorders, which can result in different problems. And for today, a major part of diets to pigs and poultry include vegetable ingredients, and those contain around 30% of the phosphorus that pigs and poultry actually need. And even then, only half of this amount is absorbed by the animal. And the typical form of feed-grade phosphate that we add to the feed is the monocalcium phosphate, which we call MCP. This is a highly soluble additive, allowing for increased flexibility in the diet formulation, and it's easily digested by the farm animals, meaning that less of the feed additive is wasted, and that means lower impact on the environment. But as we just heard, the raw material is a finite resource, and it's listed on the critical raw material list. And that's why also this recycled phosphate is a very interesting and important and promising option to replace, for example, the monocalcium phosphate with. So, digestibility of phosphorus, why is this important? Well, the digestibility tells us the amount of phosphorus that can actually be absorbed and utilized by the animal. And knowing the digestibility enables us to compose feeds with the right amount of phosphorus, and thereby also optimizing the animal's performance and reduce the excess of phosphorus in the manure. So in the project, we conducted two digestibility studies, one with growing pigs and one with growing chickens. And the aim was to determine the phosphorus digestibility of this recycled precipitated calcium phosphate, which we call PCP. The hypothesis was that PCP should have a similar phosphorus digestibility as the monocalcium phosphate in pigs and chickens. So in the chicken study, we used 240-day-old chicks of the breed Ross. They were divided in 30 groups with 8 chickens per group. And in accordance with suggested method to determine the digestibility of phosphorus in chickens, 5 experimental diets were composed. It was a basal diet that was used to fulfill the protocol requirements that is stated by the World Poultry Science Association. And in addition, 2 test diets for each of the 2 test sources, PCP and MCP, were composed with the aim to achieve an increase in the total phosphorus level in the diet compared to the basal diet, that is, with then 0.075% in the low diets and 0.15% of phosphorus in the high diets, respectively. And the study started when the chickens started to eat this diet when they were 21 days old, and it continued until they were 28 days. So the chickens in the different test diet groups, they ate the same diet throughout the whole period. And in the end, the chickens were slaughtered and we collected the ileal digesta. The pig study consisted of 8 9-week-old gilts, Yorkshire, Hampshire breed, and they were from 2 litters, and they were randomly divided within the litter into 2 treatment groups. The test diet with PCP as the phosphorus source and a test diet with the monocalcium, the MCP phosphorus as a resource. We also gave the pigs a basal diet that was phosphorus free prior to the test diets in order to estimate the endogenous phosphorus losses. And this was performed in a changeover study design. That means that all the pigs ate the basal diet first, and then they switched to one of the test diets per group, and then after a while they also switched diet again. So every pig ate both two test diets. And each of the experimental period was 7 days of adaptation to the nude feed, and then 4 days of fecal collection in each pig then. So we get samples from each pig and each diet. In all feeds, titanium dioxide was added as an indigestible marker, and this component was not digested or is not digested by the animal, and thus it's also present in the ileal digesta and the feces. And we use that to calculate the digestibility of different nutrients. Yes, feed, digesta, and feces were analyzed for dry matter, crude, protein, titanium dioxide, calcium, and phosphorus. And we calculate the ileal apparent digestibility and the total tract apparent digestibility for the diets with this formula, this equation, which shows the ratio of the difference of the ingested and ileal or fecal phosphorus to the ingested phosphorus, and it's expressed as percentage. And according to the literature, the method to determine the ileal digestibility for chickens, the pre-cecally digestible phosphorus should be put in relation to the total phosphorus content in the diet, and thus this was also needed to be calculated. And we did some common statistics in a mixed procedure to determine treatment effects by an ANOVA model, which included diet as a fixed factor, pen or pig as a random factor. And in the chicken study, the literature also suggests to include a regression analysis to the statistical model showing the linear relationship between the digested phosphorus to the total content of phosphorus in the diet. So this is then used to estimate the ileal apparent digestibility of phosphorus for those tested sources. And some quick results from the chicken study. This is the figures of the ileal apparent digestibility in percent of nutrients in the total diet. So we could see that the digestibility of organic matter and calcium did not differ between the diets, whereas we saw a difference between the diets with low and high inclusion level, a difference of the pre-cecal digestible phosphor and the phosphorus for digestibility for the diets. This figure illustrates the linear relationship between the pre-cecally digestible phosphor in grams per kilo diet and the total phosphor content in the diet. And it is expected to be a more digested phosphorus pre-cecally with a higher level of total phosphorus in the diet. So here we see the basal diet. We see the, let me see if I have a laser pointer. We see the basal diet here, the groups that had those, and here we have the low inclusion level for the two diets and the high inclusion level. So we see the linear relationship here. And from this relationship, the ileal apparent digestibility from phosphorus from the two sources of MCP and PCP could be calculated and was estimated to be 75% for the MCP and a little bit over 58% for the PCP. From the pig study, we calculated the total tract apparent digestibility of nutrients in the diets, and we found that we didn't have any difference between the diets for organic matter, the digestibility of organic matter, but there was a difference between the diets for the digestibility of calcium and phosphorus. So to sum up this and conclude this a bit, we found that we estimated that the phosphorus digestibility of the MCP in the present study was within the expected range according to the literature. So this was good. And we also found out then that the digestibility of phosphorus was lower for PCP than for MCP for both chickens and pigs. We did find a linear relationship between the content of pre-sickly digestible phosphorus and total phosphorus for the chickens. And the digestibility of calcium was similar in the diets with MCP and PCP in the chicken study, but it was lower for PCP than MCP and in the pig study. We also can conclude, and we did know that this, according to the literature, was the first time that phosphorus digestibility of this recycled phosphorus source is determined in vivo. Our hypothesis that PCP should have similar phosphorus digestibility as the MCP in pigs and chickens could not be supported by this study. But we think that to fully explore the potential of PCP as a feed ingredient, as it is an interesting and promising option, more digestibility studies and also feeding and growth studies are needed. And the benefits of closing the phosphorus cycle, also having domestic production of phosphorus and with decreasing carbon dioxide emissions, should be considered. And by that, I also want to thank our co-partners in this project, in the project group and reference group, and those that have been working with composing the test diet, the feed, and also the financial support by Lantmännen Research Foundation and Ragn-Sells. Thank you for your attention.
So thank you very much indeed, Magdalena. That was very detailed. I think I learned a lot more than I'd imagined about these processes. Before I come to our next speaker, I just want to let the audience know that we've got a bit of a problem with the YouTube chat. And if you want to ask any questions of our guests and the next guest coming up, then could you email your questions to Lisa Holmberg? Now, I'm going to spell this out. It's LISA dot or punct HOLM for mother BERG at Ragn-Sells, RAGNSELLS dot or punct.com. So lisa.holmberg at ragnsells.com if you want to fire some questions over, and we'll get that sorted out. All right, so now we're going to move to our next speaker, which is Dr. Sarah Stjernstrom, who's product manager of EasyMining. We introduced her earlier, and she also is a scientist. She's got a PhD in ecotoxicology and has been the project leader of this feed project working group with some of our guests. Your theme, Sarah, is quality before origin, which sounds very mysterious, but I'm sure we'll understand more. Legislative barriers. So, and I think this probably gets us to the kind of nub of this challenge, which is what's policy and legislative things saying about this recycled product. Over to you, Sarah.
Thank you, Nick. Thank you for that introduction. Let me see if I can just do the right. Yes. So I'm the super proud project leader of this project, testing the PCP in feed. And I'm so happy to be here with you guys today. I would like just a few minutes to put some more spotlight on the legislation. So let's come back to this picture again. You saw it in Yariv's presentation, and this is a really important one because this is what needs to happen. This is the goal. Resources are circulated and create a closed loop. And we collaborate and we create a circular economy for real. So this is the goal. But to make this happen, we really also need the legislation now to focus on circular business. We need help from the legislation for sure to make this happen. And we see some positive trends with upcoming and new legislations on the way. And this is great. So we have, for example, the EU taxonomy on sustainable financing, pushing for 80% recovery of P from wastewater treatment plants, and a demand on purity also on the final products. So this is really interesting and something that can help push. We see the upcoming new sewage sludge directive as a really important one. What I was saying, and again, this is the goal. We saw it in Yariv's presentation, and this is what we need to do. We need to circulate, we need to close the loop, collaborate, and we need to do circular economy for real. This is the goal. We have some positive trends for sure in the legislation and upcoming legislation, and this is really important. We need this push for recycling and the push for high quality products. And as I already said, we have the EU taxonomy on sustainable financing, pushing for 80% recovery of phosphorus from wastewater treatment plants and a demand on purity in the final product. This will be super important. We also have the upcoming sewage sludge directive, also pushing for decontamination of sewage sludge via limits on sludge use. So this is also super important. Another upcoming directive is the urban wastewater treatment directive. And here we will hopefully see a push for recovery demands in the wastewater treatment plants. EU has also a new super interesting EU soil strategy. And here we will see a push for zero pollution, non-toxic soils. And finally, in my examples, I have the carbon border adjustment mechanism, a really important one, because this will redefine value chains. It will favor domestic phosphorus by adding a tax on important phosphorus from outside Europe. But if we look at the specifics here for feed, we have a stop sign. You saw this already in Ludwig's presentation, that a product recycled from sewage sludge to be used in animal feed is prohibited today. So even though we have the push in legislation for recovery and more recovery of phosphorus, it cannot enter the market. We have a stop here. That's a problem. And this is in regulation 767/2009. And I think back then it was the mad cow disease putting this as the main aim to stop. And for sure we need safety, for sure we need pure products. But I think we are ready now when several of recycling companies, our colleagues, wants to enter the market with high purity products. And finally, the way forward is, of course, to open this legislation. We need help now to open it, and we need to reverse it. We need to focus on quality instead of origin. We need and we also need legislative incentives for the production industry. For example, quota systems. And we need to make ash a safe starting point. Like Ludwig also told you, that's a possibility. Ash could actually be a really safe starting point because, you know, incineration destroys all pathogens and organic contaminants. And adding on that, chemical recycling could really be a safe way of making a pure product. So my take-home message for you guys is today, please let the feed market be part of the circular economy. We need to open this legislation and we need to do it for high purity, safe materials. So back to you, Nick. Thank you so much, and sorry for not having the presentation ready as I thought I had.
Hey, Sarah, don't worry about it. I mean, how can it be 100% perfect when you're doing all these technical shows? So I think you did a great job. Thank you very much indeed. Now we come to our last speaker in this first section, and that is Kirsten Sigfridsson, who is an expert in pig nutrition and the optimization of feed at Lantmännen. Lantmännen, if you don't know them, they're an agricultural cooperative and Northern Europe's leader in agriculture, machinery, bioenergy, and food products. It's owned by 19,000 farmers, has operations in 20 countries under this wonderful slogan, "Together we take responsibility from field to fork." Now, Kirsten, your theme is market potential for sustainable products. Over to you, Kirsten.
Thank you very much, Nick, and good afternoon, everybody. Well, there were some chickens on the invitations. As you already know, I'm a typical pig person, so I managed to put some pigs on this presentation as well. The subject is market potential for sustainable products, but I added with focus on feed phosphates. And now you, of course, wonder how I ended up at this meeting. I think there are two main reasons. When EasyMining presented their idea to recycle phosphorus from sewage at Lantmännen several years ago, I was in one of the first meetings, and I've been following this project ever since. The second reason, I guess, is that being responsible for the nutritional value of Lantmännen's pig feed portfolio, I have some power when deciding what raw materials can be used in the diet. That Lantmännen entered this pioneer project was not a coincidence. See if I can manage to change picture. Yes, I could. You already heard that Lantmännen is a Swedish agricultural cooperative with owned by the Swedish farmers and working mainly in the northern part of Europe. The Lantmännen motto is to work from field to fork and sometimes back to field again. And this strongly indicates our focus on sustainability and circular economy. So from field to fork. If you look at our main business areas, it's no surprise that the agriculture sector is the main business, but we also are very strong on the food side. And then we have the energy sector that is also growing. The field to fork strategy is shown on this scheme as well. The most business of Lantmännen's business is started here with the grain business, and then we have the human side with the food and the meal and the pastas and everything. And then we have a circular flow of nutrients back to the feed and also to the biochemistry, the ethanol production. And of course, a lot of grain also goes from directly to the feed industry. And so you see the flow of nutrients here, and when the nutrients from the feed ends up with the livestock, and then it's recycled back to the farms and to the growth of the cereals. So you see that our interest is, of course, not only in phosphorus for feed, but also for fertilizers. So the circularity gets complete when the manure from the animals uses back here for the next crop. One important driving force for this system is, of course, research and development. And within Lantmännen, we have a long and strong tradition of research and innovation. And we annually invest around 250 million Swedish crowns on development, primarily to this grain chain with cultivation, plant breeding, processing, and also making our food products more delicious. Then we have the Lantmännen Foundation, already mentioned earlier here, focusing on research, on more external research, so to say. And there we yearly invest about 25 million Swedish crowns on external research at the colleges and institutes and universities. Here you see, and advantages for Swedish agriculture is always in the focus for granted projects, and also indirect or direct effects on sustainability is almost mandatory to get funds from Lantmännen Research Foundation. And here on the right side, you can see some examples of what subjects recently got money from our foundation. We work a lot with oats, good for both animals and humans, and improved precision farming is also a way to improve sustainability. In 2020, we got the application that wanted to test the digestibility of this climate smart feed phosphate made by EasyMining, the product you know quite a lot about by now. And when we got this application to the foundation, there was actually quite a big debate. So in the reference committee, yeah, you could say it was a more intensive debate on this subject than we normally have when we discuss the different projects we have on the table. It started up a bit negative because people were a bit afraid of this issue. Actually, is it even possible? Can it be done clean enough? And will the EU regulations ever change, or how long will it take to do that? And some persons thought that it will be a waste of money to spend it on a digestibility study before we knew more about the future for these products. But then we realized, of course, that we will run out of appetite phosphorus to mine, and Europe has limited findings of this crucial nutrients, and we all know by now what politics can do to raw material supply. So the project was approved. And that was a very, very good decision because it has been a very good project, perfectly and well executed, and with results that show that even 100% perfect, it's still good enough to use in animal feed. At least that's what we hope. So I will end my presentation with the final question that we, as a feed industry, of course, got from EasyMining. Will you buy it? Will we buy it? And I had the discussion with my colleagues on the purchaser department, and we ended up with an answer like normal. It depends. Of course, the legal matters must be straightened out, and it must be allowed. And we have our quality standards at Lantmännen that needs to be fulfilled. And then there is the debate on the digestibility study. But I think you could say that they are promising and workable, even though they are not as high as for the phosphorus we use today. But you can also say that there is still still room for improvement, and perhaps also time for improvement. And then, of course, the last question is, will the price be competitive? And if the answer is yes to these questions, I'm pretty sure that we will use recycled phosphorus of high quality in our feed products for the future. And I'm also quite positive that Lantmännen will continue to work for an increased use of recycled raw materials in our products. And it's most likely that the Lantmännen Research Foundation will support similar projects for the future. Thank you very much for your attention.
Thanks, Kirsten. That was super. If we could only take that little red approved sticker and put it on the top of the EU's buildings in Brussels, then we would have solved the entire problem. So thanks very much indeed. Okay, so we're a little bit behind schedule. I'm just looking at my clock here. Yeah, so not too bad though. I think Per, my co-host, maybe we can just do maximum 2 quick questions and quick answers from our guests, and then we'll go to the second half of our show.
Yeah, it has been amazing to see the number of questions that are coming in, and we promise to answer all of them. I would like to first put the question from US, and this is Ed Weinberg talking about if there's any poultry litter or chicken manure with the digestibles that is subject for material P recovery or reuse. And on that matter, we had the session about exactly that at the COP conference, where we showcased what is now ongoing in Denmark with the Minister of Agriculture from Denmark as the forerunner. I would like to close the loop. But I would like to ask Jariv about that question. Is it possible, because now we talk about sewage sludge, is it possible to use the technique for also other streams of phosphorus?
Yes, I would say that if you incinerate animal manure, you get an ash that is high in phosphorus and potassium, and you can, with similar technologies, extract the phosphorus in a pure form that can be recycled for feed and fertilizers.
Thank you, Yuri. That was a very clear question. We will come back to you, Ed, with your other questions and reply to them. I have one question to Ludwig, if I can just, that also had popped in here. You had a lot of numbers in your presentation, but how much phosphorus do you see is possible to recirculate from sewage sludge if all sewage sludge in Europe is used? Do you have any number of that one? How much phosphorus of the need do you think is possible?
We have approximately 600,000 tons of P in sewage sludge. So if you put that into relation to the total phosphorus use that we use for feed and fertilizers, we use about 1.5 million tons in Europe. Everything expressed in P, in nutrient content. So you can see that not the half, but little less than half of the need could be covered by secondary resources.
Thank you so much, Ludwig. We will come back and answer all the questions separately to you that have raised them. And I hand over now to you, Nick, again.
Yeah, thanks a lot, Per. Good, great to see some questions coming in. We're now going to go to the second half of our show, where we're going to have a panel discussion. It's going to involve Per, so Per, stay with us on this. But also we're delighted to have with us Peter Helander. He's a member of the Swedish Parliament with the Centre Party, and also Marcus Selin, who's also a member of the Swedish Parliament with another party, the Social Democratic Party. And with us, we also have Anders Wickman, who I don't know if you have been long in the environmental and sustainability space, but if you have, you must know Anders, because trying to introduce him is really impossible. He's got so many credits to his name. A former member of the European Parliament, honorary chairman of the Club of Rome, chairman of Circular Sweden, and a leading and long-standing member, which is from where I know him, of the UN Environment Programme's UNEP's International Resource Panel. So Anders will conclude this session, which is super, and you can jump in as well, Anders, during this debate. But let me first turn to Peter. Peter from the Centre Party. Can you give us a little perspective on this topic in terms of, I don't know, it might be a personal opinion, it might be an opinion of the party itself that you represent, on this issue of bringing phosphorus back to life from recycled sewage sludge. Yeah, it's all about the circular economy, Peter. Over to you. You have 3 minutes.
Thank you very much, Nick. And thank you very much for interesting presentation. I will try to talk about how we politicians can encourage recycling goals and improve the legislation. For the last 2 or 3 years, our Centre Party, which I belong to, have proposed a number of regulations. A national recycling goal, for example, for phosphorus and nitrogen of 50% and 50% respectively. And we have also proposed that water treatment plants in bigger cities should have higher goals, and they should be increased over time as technology improves. Using sludge and is one of the best allies in our part of greater resource efficiency. The national recycling goals sends an important message from the state that we support the technological innovations underway and wish to see more investment in the water and sewage sector. We have also proposed change in the legislation in this field that is one of the primary obstacles in reaching a full circular economy. We strongly believe that a resource should be valued on its quality rather than its origin, as mentioned before. As the innovations Ragn-Sells develop shows, we can obtain phosphorus from sludge and sewage at a much higher and purer quality than we import outside from Europe, and instead of a new virgin resource. And of course, this is important for both phosphorus and nitrogen, and also for a lot of other materials as well. And a part of this has to do with changing the Swedish law on waste and changing the waste hierarchy to resource hierarchy. We also want to see more liberal regulations on who can handle, transport, and process waste or other resources, both within Sweden and within EU. And we also would need to review and modernize the Swedish legislations for when it comes to giving permissions and licenses for new technologies and new sites where these can be implemented and tried out. At the EU level, we also wish to see a mandatory quota on using recycled phosphorus and nitrogen fertilizers, as well as developing a certification system for climate-friendly nitrogen. Sweden could be a pioneer, but ideally, we want to see the EU committee or commission take greater steps sooner. And over to you, Nick, again.
Thank you very much. Well, that's pretty clear. Thank you very much indeed, Peter. Marcus, from the Social Democratic Party, is there a position on this topic from your side?
My position. Thank you, Nick, and thank you to you all for very interesting presentations. Very good presentation. Thanks. First, I would like to reveal a little secret. Actually, for 15 years ago, I started my career as an engineer. So I have designed plants and mills and so on. So this is like Christmas for me to be with you today. But as Nick mentioned, I'm a member of the parliament today. So now we'll go back to the politics. So my first thought is that we have to start in the big picture. View a rhetoric question: is there any politics in this? Of course, the answer is yes. Even the view on the cooperation and the EU is political issues. So it's a reminder for us all during times of Brexit and COVID and how we will and we want to cooperation over borders. So that's politics as well. So more the view on the new recycling and view on recycling. I'm thinking of the recycling as a process, because Sweden, we are an engineering, not an engineering company, but a land of engineers. Actually, we have a lot of competence and companies within recycling and mining and steel production. So we have the know-how, and I would like to do some commercials as well. EU has an industry strategy as well. EU has pointed out a lot of critical processes and thoughts about the future, how we can handle this circular economy in the future as well. So what I am meaning now that say that I think this kind of processes ideas, it's perfect timing in the right spot. So I'm very optimistic when I looking this kind of processes. I'm not so worried. I think we will see much more of this in the future. But as many of you have mentioned, it's a matter of push and pull. I worked as a market director as well, so I know the issues to handle regulations and create and as political ease the market mechanism. But we would like to see the market can handle it in the future for itself. I will thank Sarah Schenström for the concrete, very good example of what we as politicians can do in the future as well. So this is my first reflection. So, thanks, Nick.
Yeah, thanks very much. I mean, it just seems to me, and I'm a lay person on this, I'm not a politician, but I am just an ordinary person. And just looking at the presentations we had earlier, it seems a lot of the heavy lifting has been done. You know, it's not a theoretical issue. You know, it's there's a plant being built in Germany. There's a process that EasyMining has developed. It's gone through trials. Maybe it needs a few more trials, but that's another matter. And yet there is this kind of elephant in the room, which is this notion of, well, you can't kind of use sewage sludge, nutrients out of sewage sludge. I mean, it doesn't seem to me that the circular economy concepts of the EU have maybe caught up with this. And I just wondered, is it because this topic falls between different ministries? Is it an environmental topic and it's really handled by agriculture, or is it an agricultural topic that should be handled by environment? Sometimes in government you have cracks, you know, between different ministries. Or is it that we need a leader? Do we need Sweden to just move forward on this? And basically in the end, the rest of the EU will see, there's a leader, this works, let's just adopt it. Or is it Germany? Do they need a little push as well? I don't know. I mean, Anders, you're with us as well. I mean, we want you to reflect on this more broadly at the end, but why is there this kind of intractable sort of blockage in the pipe over the use of sewage sludge? And how can we unpick this in the government?
Well, I think you indicated in your question the answer. And I think we are faced with a problem that so many of the challenges we face in today's society are very complex, and they require a systemic perspective and a solution which takes into account many factors at the same time. And having been close to politics for quite some time, my conclusion is that we still have, or there is a lack of governance structures at government levels, and this includes the European Commission, which really tries to address this in a systemic way. And I mean, there were examples given about all the directives that are now coming on stream, and yet we have this regulation 767, which seems to block progress in this particular area. And I would like to get all the commissioners together who by any chance are involved in all these directives, including 767, and they should come out of the room until they have a solution. So I think it is very much a systemic problem.
Marcus and Peter, let me just come back as you as parliamentarians in Sweden. I mean, could there be some way of, I mean, I think this is not an insignificant topic, right? I mean, it's actually quite an important topic. And when it's presented through the security, through the globalization story, through the supply chain story, through the climate change story, when you see it in that sort of big picture, it's a very interesting topic altogether. And I just wonder if there's some way of creating a kind of a cross-party initiative on this within the Swedish government, and Sweden becomes the leader that, in a sense, shows the rest of the EU that this is possible? Because I don't know if you started using this as feed in animals in Sweden, would somebody from Brussels come and shut you down? I mean, how does that work? I don't know.
I might give you an answer. In Sweden, we are very afraid of Brussels. We do everything they say, and we don't try to violate any regulations. We are good Swedes doing everything correct. I think that there's a window of opportunity just now, because I'm talking to the farmer organization, and they are talking about they maybe won't do the spring sowing due to lack of fertilizer / price of fertilizers. So there is a moment now when we could start to recycle the products that we need, because everyone knows that we must do it, because we don't have fertilizer enough, and other problems. One problem that I have, that if we should regulate this, it should be in a way that, because Sweden is very, we have people living far out on the countryside in small villages, so we don't make regulations that they have to, in their little water-based plant, have to have these big things to do to take care of everything, because the expensive will be too high. So therefore we are talking about bigger water plants in the big cities to go first, to lower the cost to do it in the smaller cities later on. Thank you.
Yeah, and I can answer as well, Nick. Is it okay? So I can sketch up 3 or 4 potential answers on your question. Actually, the first thing is I'm thinking of price. We're meeting a future with lack of phosphorus, so that will affect the price. I'm quite sure that this kind of plants will find this kind of plants in more places, in more land, more countries. So that's one answer. The next thing is it's new things. We humankind, we are always a bit afraid or thinking of meeting new things. So this is some kind of change management. And don't forget, I know that you know this, but we have a lot of parallel processes going on for the moment. This is not a phosphorus problem we have in the world for the moment. We have viruses and we have the CO2 as well. And you understand, we have a lot of problems going on for the moment. So I'm more and more thinking of the price mechanism in this case, because we all agree that we will have a lack of phosphorus in the future. So this will give us more pull effects from the markets and better plants as well. So thanks.
Thank you. I mean, Anders, maybe we can come back on this. I mean, you know as well as I know that governments only tend to respond when there's an absolute crisis in front of them. They're a bit slow at planning long-term over things. I mean, maybe, you know, if it was gas that we were talking about, everybody'd be panicking, right? But I mean, phosphates could be switched off at some moment if the geopolitics switch even further.
But let's start with what are the opportunities for Sweden? Well, Sweden is in the presidency of the European Union the first part of 2023. So a year from now, Sweden will be in the presidency, and this issue could, of course, be put on the agenda for the Swedish presidency. But then we would have to start preparations now, and I would think a small task force, a small group doing that would be very interesting. Secondly, it's been in a way ironic. I mean, we've had now discussions on circularity and the circular economy for almost 10 years in the European Union. I don't know how many conferences have attended. And the terminology circularity, it originates from nature. And yet we have talked very little about nutrients. And we have talked very little about nature-based solutions. We have talked mainly about the technosphere, about recycling of plastics, of metals, of minerals, of textiles. And these are very important issues. But unless we realize that nature is part of this picture and has to be part of a strategy, I think we are failing. So I would like to put nutrients back on the agenda. Our Finnish friends have spent much more time on the nutrient issue than Sweden has. Thirdly, I think we need also to bring back the systemic perspective overall to the circular economy. We have a tendency to look piecemeal at this. For quite some years, we only talked about recycling. The product life extension was never really mentioned. To reuse and recondition was hardly mentioned. To turn products into services was hardly mentioned. We have to talk about the whole. Otherwise, it's not going to work. And we also have to look at the barriers for change. Both my colleagues referred to economics. Well, economics is crucially important, but we have a situation today where in most cases, virgin materials are less expensive than secondary materials. And as long as this is the case, we won't have traction. We have to get some dynamism in this. So I would like to participate in a small task force, trying to put nutrients back on the agenda and to demonstrate that unless we welcome technologies like EasyMining, I don't see how we can bring or live up to the targets that are being set in the other directives for phosphorus recycling and reuse. I don't see how that can happen. And I don't see any other technologies where you can retrieve nutrients the way this technology can in a safe and a secure way. Maybe there are some, but I haven't been exposed to them. And we simply cannot continue to just spread sludge the way we do on farmland. If we can find solutions to this, I think everybody would be happy.
Really good point. Per Larssons, you wanted to come in on this.
Yes, reflect a little bit about Marcus said about the market. And because the challenge is if we're going to regulate everything, it will take huge amount of time. So can we create the market potential? And I think that Ludwig really had the solution. The EFSA report talking about it's safe to use if you have ashes as a starting point. So to be honest, the blocker in Europe at the moment is Digestibility. So therefore, politicians, we need to address then the commission to say, you're not allowed to block it anymore. We need to move ahead to make sure that we create the market. So that will be a real big request. And I agree with you, Marcus. There's a lot of places around the world where this innovation is needed. I remember in 2018 when we visited New York, and I personally met with the city of New York, and they have a huge problem from 2030 with this sewage sludge. And we see the same thing all over all mega cities around the world. So there's huge potential, but please create the markets and it will happen. I can guarantee you. And the cost for society will then be reduced.
But I would like to say that markets are very important, but they will not happen by themselves. And as long as there are market failures, and as long as the market doesn't cover all the aspects, I mean, there are benefits, there are co-benefits which are not easy to assess for a single user. That co-benefit may be for society at large. So that's why it's so important to have the political sector and the commercial sector working very closely together.
I totally agree on this.
Can we just, we're getting right pretty much on the wire now for ending this show. I know, I can see Marcus just wanted to chip in. Marcus, please do.
Yeah, I would like to thank Per. I understand. Thank you. I take it with me that the message is quite clear. And maybe we have something going on for the moment. It's a fight of and for nature resource, and semiconductors and what you want. So something is happening, and this will, in my point of view, this will make new markets and probably circular economies going on in a better way than today. So thanks.
Okay, I think we're at the end. Per, do you want to just have the final word? We have a little thing here. It says in the program, sum up by Nick and Per. So I'm not going to sum up too much, but maybe Per, you could say something. And I think the only thing I would say is that I think it's great if you get the whole EU machinery on board with this, but I still think you need leaders. And I must say, during the COVID pandemic, every country was adopting its own rules about how to behave with COVID-19, which maybe wasn't the best thing, but you know, you can sometimes you have to have somebody to take the lead, and that's what I slightly think. But I'm no expert on this. Per, come, tell me what you think.
I would like to hand over my minute to Anders and give the floor to you to really have the concluding remarks. And because I think what you have said about creating a task force to really and cross nations, we need to understand we can't do that solely. We need to have other nations participating in this program. So please, Anders, go ahead and do your closing.
Yeah, Anders, do that. Maybe you could use UNET plus 50 in June as a perfect platform for this formation of this task force and the first event.
Well, it definitely has to do with food security in the long-term perspective. Of course it has. So yes, it could be an important topic there. I'm, as a matter of fact, working on a report together with the Club of Rome, the Potsdam Institute, the Stockholm Resilience Center, where we focus on a turnaround when it comes to food systems. So that could be part of that agenda. I fully agree. But what I think is so important is, again, to stress the systemic nature of the problem and the need to try to take account for and assess all the benefits from a new approach, and not think that you should measure or account for only part of it. And we haven't talked about this today, but the court case in Helsingborg a few months ago, where Ragn-Sells was very much involved, was a perfect example where they had a too narrow approach. You have to have a much wider approach when you look at all these issues. And I think we find in other areas of the economy also where the way residue materials and waste are being looked upon is not in conformity with the circular economy approach. So we have to take a fresh look at all this, including legislation. And of course, the nutrient aspect is critical. So some kind of a task force here to really push this issue, I think would be very, very welcome. Thanks a lot.
Thank you, Anders. Thank you, Pers, my co-host. Thank you to all our guests, and thank you to EasyMining for helping to set up this webinar seminar. Hope people learned something, and obviously there's a bit of work to do, but it's certainly a fascinating new approach to the circular economy, and let's hope it goes a lot further than just this seminar webinar. Thank you very much indeed. Bye-bye, everybody.